Okay, let's do this first example here. We're given a point. In fact, we can so we've got 5, 1, 2, 3, 4, 5, and then we'll want to go over 1, and then up 3, 1, 2, 3. So we want the line that passes through the point 5, 1, 3, and is parallel to I forward plus 4j, and then minus 2k. So that is kind of going down. So we want something that is going kind of, the line to be going in that direction, if that makes sense. This is just a rough sketch. Okay, so the first thing we're going to do is for our vector equation, remember we've got our formula, and our formula is R equals R naught plus TV. Okay, now R naught is supposed to be the position vector through the point that we are given, and we were given the point 5, 1, 3. So that corresponds to the position vector 5, 1, 3. So this is going to be our R. Okay, and now our direction vector is going to be 1, 4, negative 2. Okay, so let's write that down. So 1, 4, negative 2 is V, and our R is 5, 1, 3. Okay, so it looks like we will have, as our final answer, R equals 5, 1, 3 plus T times 1, 4, negative 2. Okay, and this is a vector equation. Now, another way to write this, another way we could write this would be, we could also write it as 5 plus T I, okay, plus 1 plus 4T times J plus 3 minus 2T times K. So we're now just writing it using the components, the IJK components, and that is equivalent. Okay, the second thing we need to do is write our parametric equations. And let's see here. So going back for our parametric equations, remember, here we go. We've got x, y, z. Here's the deal. Do you see here how we actually wrote that our x component is the x naught plus at, the y component is y naught plus bt, and the z component is z naught plus ct. So the fact that we just wrote our vector equation like this now gives us a head start on writing our parametric equations, because they will just be we have x equals 5 plus t, y equals 1 plus 4t, and z equals 3 minus 2t. Okay, so those are parametric equations. And notice that we could really write these in terms of, if you're taking linear algebra, you might see this. We could write this in terms of x, y, z equals 5, 1, 3 plus 1, 4, negative 2 times t, right? So if we write out our vectors as columns, that is exactly the same as what we have here. Okay. Oh boy, sorry about that. Okay, and then the last thing we're supposed to do is we're supposed to find 2 other points on the line. Okay, so remember, if we want to find points on the line, then do we use the vector equation or do we use the parametric equations? we use the parametric equations, right? If we use the vector equation, we'll get vectors. So let's just use the parametric equations. And to get two other points, let's see if we can fill this out. What happens when t equals, so we can put in what happens when t equals 0. We already know the point we should get is going to be 5, 1, 3. So all I did was plug in t equals 0, right? If I plug in t equals 0 here, I'm going to get 5. And t equals 0 here, I'll get 1. T equals 0 here, I'll get 3. At t equals 1, what do I get? I will get 6, 5, 1. And then at t equals -1, I will get 4, -3, 5. Okay. Okay. And so here we have the solutions here. Same thing. Just different notation. And this is a better sketch. So I wanted to include this because this is a better sketch than the sketch that I have. So that vector, we've got our vector here, which is giving us direction. I plus 4j minus 2k. That gives us the direction. And then this vector R naught gives us the point that is on the line. Okay. So it's like that vector did come out like that. That was the V when you translate it. And now all these points here correspond to R equals R naught plus a scalar multiple of V. Okay. And then this is what we did here. We just chose to plug in different values for t. T equals 1, t equals -1. And those values correspond to, let's just to clear it up here. So t equals 1 would correspond to, what do we get for t equals 1? 6, 5, 1. 6, 5, 1. Which I guess would be 3, 7, 6, 5, 1. Yeah, I think this would be t equals 1. And then t equals -1 will be the vector that is back that way, right? So like this is V and this is -V, right? So adding V and then subtracting V back that way. Okay, very good.